Alright, this is Unit 5, Lesson 9, talking about functions and relations. And you got your one objective there. Let's go ahead and get started. Okay, recall from an earlier lesson that we did that a function has exactly one output for every input. This is true for all linear functions, okay, and it says defined by the rule y equals mx plus b. That just means any equation that we can write with y by itself. Okay, it doesn't mean it has to start in slope-intercept form. It could be like 3x plus 4y equals 6. We could still write that in y equals form. So let's look at this a little closer here. I made an input-output table with our inputs we usually use for graphing. And notice here, if I was going to write ordered pairs for these with inputs and outputs, okay, -2 and -3 and -1 and -1 and 0 and 1 and 1 and 3 and 2 and 5. Okay? Now your book is going to write some input-output tables where we like them like this, okay, for graphing. You're going to see some input-output tables where they list your inputs. So those are inputs are -2, -1, 0, 1, and 2. And they'll list our outputs. And then they'll just match up the ones that go together. Like this. Okay? This is a function, because there's only one line from inputs to outputs, okay? For this input, there's only this output. For this input, there's only this output, and so on down the line, okay? We don't have more than one output over here for any of these inputs. The inputs never repeat themselves, okay? So that means it's a function, because for every input, there's only one output. Let's look at when this is not the case. Okay, there are rules for associating more than one output with an input, and that's called a relation. Okay, an equation where an input can have more than one output is called a relation. And here's an example of that. So let's input a number in for x. Let's say for x, we want to put in, I don't know, let's go with 1. Okay, so we plug into our table here, 1 equals y squared. So this means that 1 equals something times itself. So I'm going to ask myself, what times itself gives me 1? Well, 1 times itself gives me 1. But then I'm stopping thinking to myself, well, that's not the only way that I can take a number times itself and give me 1. So if I put in 1 again, what's another possible output I can have here? If I put in 1 to x, another possible output I could have is -1. Because -1 times -1 gives me 1. Okay? Now, again, let's do another number. Let's say I put in 4. Well, 2 times itself gives me 4. And -2 times itself gives me 4. Okay? We can go ahead and continue our table here a little bit. So now if I put my inputs and outputs and write them as ordered pairs, I've got 1 and 1. But I've also got 1 and -1. And 4 and 2. And 4 and -2. So notice what's happening. My inputs, my 1s, have 2 different outputs here. Okay? And my 4s have 2 different outputs. So that means that this is not a function. And in your book, you'll see some input-output tables written like this, where they'll put an input of 1, and then they'll put another input of 4. So here's my inputs over here. Then for outputs, I would have 1, -1, 2, and -2. And the input would have more than one output. Okay? Again, this is not a function. Because our inputs have more than one output. Okay, not a function. Let's go on to some more. So now it says to determine if each relation is a function, and if it is a function, give the domain and the range. Okay, well, if we look, remember, for every input there can only be one output. So from each of these inputs, there can only be one other output. So the inputs can't repeat themselves. So if I was going to make ordered pairs out of these, I've got a 1 and a 2. And a 2 and a 4 go together. and a 3 and a 4 go together, and a 4 and a 5 go together. Okay? My inputs never repeat. For 1, the only output is 2. For 2, the only output is 4. For 3, the only output is 4. And for 4, the only output is 5. So this is a function. Okay? And the domain, remember, is the inputs. So 1, 2, 3, and 4. And the range is the outputs. I got 2, 4, and 5. Okay? So yes, that is a function. Now let's look at our other table here. Match the inputs with the outputs. Well, I've got an input of 1 that goes with an output of 5. Input of 1 that goes with an output of 7. Input of 2 that goes with 7. Input of 3 that goes with 9. And input of 4 that goes with 9. Now I've got a problem here. And the problem is right here, that I got inputs that repeat themselves. So 1 has an output of 5 and it also has an output of 7. That means it's not a function. Okay? And remember, the other word for that is a relation. Okay? So this is a relation and not a function. And we don't have to put the domain and range for this because it's not a function. And relations don't have a domain and a range. Okay? Let's go on to some more examples. When you see graphs, there is a very easy test to tell whether it's a function or not. Okay? And it says, it's called the vertical line test. A relation is a function if and only if there is no vertical line that passes 2 or more points on the graph. So if I draw a vertical line straight up and down, it should only go through 1 point on the graph for it to be a function. Okay? Well, we can test this theory here. If I was to make a vertical line straight up and down, okay, if I was to make it straight, we'll try that again here. Okay, if I was to make a straight up and down line, it only passes the function once. And another straight up and down line only passes once. And another one only passes once. So this is a function. Okay? If I did this one, straight up and down line passes once. Okay, we need to talk about function notation. Okay? In general, this symbol right here replaces y, okay, and is read of the value of f at x, or it's called f of x. Okay, so when you read this, it's called f of x. This is called function notation. Okay, so what it is y equals 3x plus 1 is the same of f of x at 3x plus 1. Saying if I plug something in for x, this number right here is going to be the value of f at x. Well, that's essentially what y is. Okay, and this is actually where notation started. Okay, when people started writing these functions, this is how it looked, and they said the value of f at x. Okay, so if I plugged in a number for x, I would get something out on the other side, and that would be the value of f at x, or f of x. Okay, well, the reason why we replaced it with y is for graphing purposes, so that we could graph these things and have an x value and a y value. So y equals 3x plus 1 is the same of f of x equals 3x plus 1, or f at x equals, or the value of f at x equals 3x plus 1. So if we want to evaluate the function when x equals 2, 0, and negative 3, we're just going to plug in those values and solve. Okay? So I'm going to say the f of 2, so when I plug in 2, the value of the function at 2 is equal to 2 times 2 minus 3. So f of 2 equals 2 times 2 is 4 minus 3 is 1. The value of f at 0, or f of 0, means 2 times 0 minus 3. Well, 2 times 0 is 0, minus 3 is negative 3. So the value of f at 0 is negative 3. Again, basically all this is doing is replacing y. And this is called function notation. Okay, this will be really important when you go on to later math, especially. So the value of f at negative 3 means we plug in negative 3 for x. So the value of f at -3 is 2 times -3 is -6, minus 3 is -9. Okay? Well, another example, g of x is also function notation. And the reason for that is because when we go later on into math, like when you get to algebra 2 and things like that, we're going to talk about functions of functions. So basically they just had to start putting different letters in for these things. So g of x is the exact same thing as f of x. Okay? It's just a different letter for a function. So if I want to evaluate g of x when x is 2, 0, and -3, I'm going to do the same thing. I'm going to say the value of function g at 2 is equal to -5 times 2. So the value of g at 2 is -10. The value of g at 0 is -5 times 0, which is 0. And then the value of g at -3 is 5 times -3, which is -15. Okay, so there's my answers for those. Okay, so when you solve these, I want you to show me this work. Okay, show me how you're plugging the numbers in, just like we did on the input-output tables, and then write your answers like this, where we say the value of f at 2 is 1, the value of f at 0 is -3, and the value of f at -3 is -9, and so on. Okay, now let's talk about how we can use these functions to graph. Okay, this says to graph the function f at x equals -2x plus 3. Well, we talked in the slides before that f of x really just replaces y. So the very first thing we need to do is replace f of x with y. So we're going to change this for graphing purposes to y equals -2x plus 3. Okay? Then what we would want to do, if it's not already, is to put it in slope-intercept form so it's easy to graph. Well, this is already slope-intercept form. So we're going to pick out our m. Our slope is -2/1. And our b is +3. So now we're going to graph these. 3. And I'm going to go down 2 and back 1. Down 2 and over 1. Down 2 and over 1. And we'll make our graph of our function here. Okay? So again, graphing functions, really easy. We're just going to take the f of x and replace it with y for graphing purposes. And then write it in slope-intercept form, if it's not already. And then go ahead and graph it. Alright? Let's go on to our last example. Okay, this says to find the slope of the graph of the linear function f. Okay, so we got the value of f at 0 is 4, and the value of f at 4 is 0. So, what I first need to do is write ordered pairs. Well, remember, this is f of x. Okay, and this was like y, f of x and y. So basically my x value is 0 and my y value is 4. So I've got an ordered pair there. Here my x value is 4 and my y value is 0. So there's another ordered pair. So the very first step on this is to write two ordered pairs. Then we're going to go ahead and put x1s and y1s and x2s and y2s, and then use the slope formula. So I'm going to have 0 minus 4 x2 or y2 minus y1 over x2 minus x1. 0 minus 4 is -4. 4 minus 0 is 4. And I get m equals -1 for my slope. So again, the value in the parentheses is your x. The value it's equal to is your y. Write some ordered pairs, then find the slope. Okay, that's it for your lesson. Good luck on all your homework.